We are talking about transformations of quadratic functions, and we want to graph quadratic functions in intercept form. We want to write the equation of a quadratic function in intercept form, given the x-intercepts and a point. So we still have the parent function of a quadratic function is y equals x squared. And the intercept form of a quadratic function is a times the quantity x minus p times the quantity x minus q. So we still have that a value. And that a value still does the same thing, where it has a vertical stretch or a vertical shrink. So we have an example in the examples over here on the right, where we have f of x equals x minus 4 times x plus 2. So the x-intercepts, find the x-intercepts or the zeros. Because the function evaluated at p is equal to 0 and the function evaluated at q is equal to 0, p and q are the x-intercepts for the graph. And the way that we can figure that out is we can use the zero product property. And the zero product property says basically, the zero product property says if a times b is equal to 0, then a is equal to 0 or b is equal to 0. And so if we have two things multiplied together, if this one is equal to 0, the whole thing is 0. Or if this one is 0, the whole thing is 0. So what you can do is you can use the zero product property to find where the parabola crosses the x-axis. So we could say x minus 4 is equal to 0. So then we add 4 to both sides. And then we get x is equal to 4. So that's one of our zeros. And we can see that we have 0.4 comma 0. And the other one that we have is we have x plus 2 equals 0. And so we subtract 2 from both sides. And then we get x equals negative 2. And so we have negative 2 there. We also have the axis of symmetry is halfway between p comma 0 and q comma 0. So basically this equation right here, q plus p divided by 2, that is just, we're just talking about the average of 2 points. So basically, we have two things, we divided by 2, we're just finding the average of that. So for our example here, we have the x's that we've calculated up here. We have 4 and negative 2, and we can substitute those in. So we have 4, and then it's going to be minus 2 for the other x. And the 2 divided by 2, that's constant, that's always going to be there. So what we end up with is 2 divided by 2, which is equal to 1. So the x-axis, or the line of symmetry, is equal to 1. Look at this graph here. We can see that from here to here, from 2 to 1, that is 3 units. And from 1 to 4, that is 3 units as well. And then the last thing that we can look at is vertex. And just like before, the vertex is always located on the axis of symmetry, and we can substitute in the axis of symmetry. That is the x value right there, q plus p divided by 2, q plus p divided by 2. That will tell us where the y value is for our axis of symmetry. So in this case, we found out that our axis of symmetry was 1, and so we substitute 1 back into the original equation. And the original equation was f of x. So in this case, we're going to say f of 1 is equal to 1 minus 4, 1 plus 2. So I have to substitute 1 into the equation. And then we get the function evaluated at 1. So then we get this one is equal to -3. And 1 plus 2 is 3. And so we get the function evaluated at 1 is equal to -9. So then we get the coordinate 1, -9 for the vertex.